All right, I guess we will kick things off and get started. So thanks for everybody for joining. This is a second part of our Backstage Pass series. This time focused on Anthos and all good things about Anthos. So plan for this event is to get into some demos again and show off some of the things the team's been working on. I have a few esteemed colleagues here with me. I'll let them introduce themselves a little bit, but we've got Tim back for a repeat. We've got Hart and we've got Greg with us today. So so same format as last time. If you haven't been here, obviously we're streaming to YouTube. We will take questions. We love questions. Let's make this interactive. The harder the question, the better. Although we may have to take things offline, I guess, if it's too difficult. Let's get into things. I'll get the agenda ready. So I will kick things off. I am your host, Kyle Bassett, hosting this event, and I will facilitate things a little bit. But the plan is essentially we're going to do a quick couple slides on what is Anthos in case you're here new to Anthos. I'll just tee up the demos and what we're going to talk about. We're going to dive into some technical presentations and show you some real live demos. So let's hope the demo gods are good to us today. If not, we will hover and pivot and do whatever we got to do to make this show go on. Obviously, question and we'll do some Q&A, but we'll try to answer them real time. Otherwise, we'll save some of them to the end. We've got a special guest again. Ahmet is on us. He's going to talk a little bit about the Knative community and do a build pack demo at the end. And like I said, we are live, so share this with your friends and colleagues, and we will also post this after the fact. So you can check it out and check out the demos. If we're going a little too fast, you can always check them out a little bit later. So what is Anthos? Anthos is a whole bunch of things to different people. It's really turned into a full solution stack from Google. It is not just another Kubernetes distribution is one of the things I like to explain right out of the gate. It's very different in the sense that it's Google's distribution of Kubernetes, but they're really making it available to run wherever you want. So we've got on-prem support, which we talked a lot about last time and showed you some demos. We also got into Anthos config management. But today we're going to move up the stack a little bit about and talk about like what the developer experience is and some of the tooling and some of the operational tooling that's useful to a developer when they're trying to host applications and manage things at scale. And we've been very lucky to be able to work with Google on all the alpha releases of this and help be a design partner. So you'll hear us talk about some community projects like Knative and Istio, but we'll also talk about Google's offerings in Cloud Run and Anthos Service Mesh. So let's get into it. So components of Anthos, if you saw the last one, if you haven't, go back and check it out. We really focused on the deployment side of things and config management, but now we're going to move up the stack into Service Mesh and Knative developer experience. So if you look at the top, if you look at from an open source perspective, Knative is the upstream project that lots of different, pretty large companies are working on. Google's version of that is Cloud Run, that has a hosted offering, but also can run in cloud or on-prem. And then we're going to get into Istio and some of the capabilities that Istio brings to the table and how Google's productizing that into Anthos Service Mesh. So you can see, the three main open source projects is Kubernetes, Istio, and Knative. And then there's obviously an opinionated kind of deployment option for GCP. So serverless, there are still servers. The operation model changes a little bit, and you don't have to worry about the infrastructure as much. It's very much of I want to run something, I want to deploy it. Think of things like in the past App Engine, you've probably heard of Lambda services like that. So it gets a little bit more opinionated and a little bit more easy to start to deploy some of these apps. And we talked a little bit about it in our last show, and Kelsey happened to pop in. He made a good point. A lot of times we refer to the model around Knative and Cloud Run is the stateless side of things, but his point was think of it as it makes you be a little bit more deliberate about state. So when you have to store things, you'll store them into something like Cloud SQL or a service around the data set and where to store things, and you focus on running the application. And the programming model is a little bit different. Obviously, you're focused from a service perspective. It's very event-driven, and I think, nowadays you don't have the option not to be open. So open source is where things are getting built and developed, and large hyperscalers and cloud providers are having to step up and start to share their knowledge and invest in some of these open source projects. So I talked a little about Knative. If you haven't checked it out, go check out the site. It'll link you to a GitHub repo. There's lots of great examples, but one of the things I really like about this project is it's a diverse project. It's being run not just by Google. Red Hat's putting a lot of work into this. You've got Pivotal, you've got IBM, to name a few. So there's a lot of big companies putting a lot of thought behind this, and it's really an add-on onto Kubernetes, and it's enhancing that Kubernetes experience. So I'll let the team kind of get into that. What is Istio? So Istio is an open source project, but think of it as it's cross-platform. There's the other piece that is getting very popular is, can I put this in front of VM workloads? Obviously, all things can't run in Kubernetes, even though some people would like that nowadays. It's a very hot topic, but we're not going to get into VM deployment today, but look for other events and blogs on some of the possibilities when putting VMs into a service mesh and interacting that way. And then what is a service mesh? I really look at it as a transparent, it's language independent. I think we had this conversation on a podcast the other day, is think of it as the old days of you'd used to tap a switch to get all the async into your network. And now you can really build this into your application and get an extreme amount of functionality into it. And just to name a few features, I mean, look at the left-hand side. A lot of people think of Istio in different ways, depending on what you care about. So some think traffic shaping, some think telemetry and insights into your application. There's obviously a big security story around certificates. And the team's going to demo some of this stuff. I know Greg's going to talk a little bit about fault injection. He's going to do some traffic shaping, things like that. And the nice part about this is a lot of the Knative stuff that we're going to show you, or the Cloud Run stuff, is all leveraging Istio underneath the covers. And we'll show you a little bit about Anthos Service Mesh also, and what it brings to the table from a GCP console view. I'll end on this slide. I think we showed this slide last time, but it really just builds up from the Kubernetes building down up into the developer experience. And I think the goal of many developers is, and operators and people who have to deploy applications, is I want to write code, I want to commit it, I want it to build and deploy, and then I want to run it. And then I want to repeat that cycle over and over again. And that's how we release faster. That's how we release higher quality code with less big bang changes. So a lot of these technologies are going to enable you to do that. So without further ado, our speakers today are Hart Ripley, Tim Fairweather, and Greg Reboul. And here's the topic. So Hart's going to dive in and do some Cloud Run, scale to zero stuff. I'll let them kind of tee up the use case. Tim's going to talk about all things CI/CD. He's become a real CI/CD guy, among other hats, I think, but lots of cool demos. And then Greg's been working on some, cooking up some cool stuff around Anthos Service Mesh. So without further ado, I am going to throw things over to Hart to tee up his use case and dive into the demo. Hart, you want me to keep the slides running? Or you want me to just push it to your screen?
Yeah, if you don't mind, you can run through them.
Okay, cool. Will do.
Alrighty, so as Kyle mentioned, I'm going to talk about Cloud Run and scaling to zero. Basically expand a little bit on the Knative stuff that Kyle was mentioning, and talk about how Cloud Run for Anthos and some of the benefits around that, and how everything is tightly coupled, but you still get the advantages of the visibility on the Google Cloud side, and the ability to run clusters in different locations. So yeah, what does Cloud Run do? Right, we're trying to simplify application deployments for the developer. We're not worried about managing the cluster. We want to focus on getting the code out, getting the application rolled out as quickly and as easily as possible, right? In terms of that, like Cloud Run will allow you to deploy all different types of code, right? Deploy your own containers and deploy services from those containers. There's a couple different ways to use Cloud Run, right? We have the fully managed service, which is in GCP, but we want to focus on Cloud Run for Anthos. Just the fact that you're using your GKE or your on-prem clusters, right, to run some of these other Cloud Run workloads, some front end services, that type of stuff. And we're really focusing on keeping everything, within the same cluster, having that same type of control and deployment scenarios there. So pop over to the next one there, Kyle.
Will do.
Cool. So I touched on a little bit of this already, but we want to minimize the time it takes to deploy an application, right? We don't want to have to go through a bunch of different levels. We want to be able to test our code. We want to be able to create different revisions and test it kind of in an area that gives us a little bit more control on the developer side, right? So we can create our own Docker containers, right, from Docker files, pretty standard. But we're also focusing on more declarative application configuration, right? So think about more Git-based workflows, defining stuff in there, using pull requests, these types of things, right? So it also gives us the ability for different revisions, right? If we roll in a new revision, something's not working, we can redirect traffic back to a different one. And obviously with the tie-in with the Anthos and the GCP side, we're going to get the built-in logging and metrics that come with the platform and with Anthos there. So yeah, you probably heard of the word serverless, right? Kyle mentioned that, but essentially, that's where Cloud Run is going, right? So it gives you a lot of flexibility, right? We can run it directly on GCP or an Anthos cluster as well. Gives you the ability to do not mostly stateless apps, but there's a little bit more to that in terms of the capabilities there, right? We integrate with policies. We're able to use IAM permissions within GCP, and obviously take advantage of some of the underlying hardware there. Scale is a big thing, right? We've titled this Scale to Zero, and I'll talk a little bit more about scaling up and down, and if it makes sense to scale to zero, depending on the application. But the nice thing about Cloud Run is it's going to auto scale based on what you've defined, or depending on the requests, that type of stuff, right? Coming in and out, and if there's no traffic, well, it's not like you have to go in and actually make any changes, right? We can the services can scale down to zero and then back up again once they start getting requests. So it's kind of the gist of it there. But yeah, we'll dive into a little bit more there. So I want to talk a little bit about what I'm going to show on the demo side. So basically the requester path here, we got your user. In this case, we're hitting the front end UI, which is hosted on Cloud Run for Anthos in our demo, right? And then we have our cluster. In the demo, we're using Anthos cluster on GKE, right? We have our backend microservices apps that we're going to use in conjunction with the Cloud Run front end, right? So instead of having everything running kind of as native services in the cluster, we're going to break out that front end into Cloud Run for Anthos, right? To give us that revision control, some flexibility around traffic inputs, and that declarative piece around the Git workflows that I was speaking about. So essentially what we're doing here in this diagram. Yeah, can pop to the next one there. And then I'm going to talk a little bit about concurrency when we do some of the rollouts of the front end, right? Kind of deciding, is it going to be kind of a one-to-one request, or are we going to have, one container serving up a whole bunch of requests? Well, it really depends on how many requests are going to come in, right? In terms of how many containers are going to be deployed from a scaling perspective, right? And be able to manage that, right? Is a container going to be able to handle 50 requests, 60, 70, 80, or is it more of a closer to one-to-one or one to a few type of relationship there, right? And then how many containers are you going to deploy, right? Based on peak workloads and downtime. So we'll touch a little bit about that in the use case demo there. So that's kind of what I'm going to cover off, so I can jump into the first demo here.
All right, let's do it. I'll throw the screen over to you, Hart.
Thank you. Cool. So what I'm going to show here is I am using Anthos config management, more so just to tie in that little piece and have the namespace and everything rolled out ahead of time. But what I'm going to do here is I'm going to create the front end Cloud Run declaration, right? So I'm just going to take the YAML file going to do everything in the GUI just for the ease of the demo. Right, but I'm going to create a declarative YAML file for the front end. All right, so we're just going to call it front end knative. And then basically I'm going to define what's going to be running the Cloud Run service on Anthos, right? So we're basically going to say, we have the vrun or v1 of our Cloud Run demo there, right? And then some of the auto scaling and stuff I'll talk about a little bit more when we go through the GUI. Container concurrency, we touched a little bit about that in the slides. And then the environment variables telling the front end how to get to the backend services or the other microservices within the app, right? Using config management, it's going to be automatically sync with the cluster, right? And I'll do I'll do the changes to it through a Git workflow to highlight some of those options, right? So I'm just going to push this. In this case, I'm not going to use a branch. I'm just going to actually roll out the service.
You did a commit message, though. That was nice of you, Hart. Not everyone does commit messages.
Not AAA.
BBCCC. Yeah, I've used a few times.
So just from the config management perspective, right, I just want to jump over and show that everything's synced, that we've deployed the online boutique app. Right now it's available just on HTTP, right? And we're going to make some changes into how that's delivered. So if we go back to the services here and refresh this, we should see our front end coming in here, right? So it's showing up in the Google Cloud Platform Cloud Run console, but we're actually deploying the container on the Anthos GKE cluster, which I will show you in 1 second here. Just going to jump into the service quickly here. All right, so some of the stuff I touched about is we get the built-in logging and metrics that we're going to start seeing some stuff like that once we generate load and add some requests inbound. But the big thing here is revisions, right? This is the first time we're rolling out this front end. So basically we have V1, right? 100% of the traffic is going to this instance, right? And at the end of the day, we can show our YAML that we committed to the repo, right? With our environment vars and stuff like that. So if I jump over here and grab the URL, right? One thing I wanted to highlight here is we can see we have this custom domain mapping, right? So what we're able to do, and to ease the developer experiences, we're able to provide, wildcard or other SAN names in the certificate. So we have public certs that are already trusted, and the app gets deployed. We have that TLS connection already available right off the hop, and we're not exposing stuff on HTTP, for example. I'm just going to pop this over in another tab here. Right, so now we're bringing up the online boutique. We can see we have our prefix here, right, of what we named our Cloud Run service. And then obviously our FQDN and stuff like that, right? We have our secure connection, right, with our trusted cert there already. So the nice thing is now we're hitting the Cloud Run front end, right? And we're not hitting, the backend Ingress gateway or the actual service like we were initially on this example here, right? So we got a secure connection. We deployed our service through Cloud Run, and we're talking to the backend microservices through the Cloud Run service now, right?
And Hart, are all the boutique has many different microservices? Are they all running in Cloud Run, or you've just chosen a few to run in Cloud Run, and then you've got other backend services in pure Kubernetes?
Yeah, that's a good question, right? So we're running we're running all the backend services on the Anthos GKE cluster, right? And the Cloud Run service is actually running inside the Knative namespace on the cluster, but we're able to see it as the cluster is managed through the GCP console. We're able to see and manage some of the content through there. So I'll show that actually.
Cool. So other services that may benefit from like high load or scaling would probably be a good fit for Cloud Run for scale up and scale to zero, and then leave your backend services that are maybe have PVs attached and things like that. Leave those running in pure Kubernetes.
Yeah, exactly. So, a lot of the backend stuff and some of the stateful stuff in there, and then some of the front end and the stuff we need to scale up. Like, if we have a storefront or something that's going to be super busy, it's going to take a lot of requests that are, up and down and different times. Ideally, you're going to want to use something like Cloud Run that's going to do the auto scaling. But we can see the backend services, are deployed on the cluster, right? And if we look here, we can see now our online boutique pod, right? So what we're seeing in the browser that I was just showing you now, we can see the actual pods and containers running inside the cluster. So when we do scaling with Cloud Run for Anthos, right, we're actually scaling pods and containers within the cluster instead of like a managed service on GCP. So your cluster is going to add those as the demand increases, right? And that's going to kind of tie back when I show some of the load demos around that, right? Cool. So we can see some of the stuff in there. I'll come back to that in a few minutes here. Really what I want to show here is kind of a little bit of a Git workflow, right? So changes. I'm going to create a new branch from master here, right? And do it the right way. Where we can create the Git workflow, the pull request, have that audit and commit and collaboration area there. So in the first part there, we created this service YAML here, right? We're going to change this a little bit and tie in some of the stuff I was talking about previously, right? So this is V1, right? We're going to make it V2. And the container concurrency here, really now we have, as we were seeing in that slide, it's not 1-to-1, right? I'm going to change container concurrency 1-to-1. And the reason for this in terms of the demo is we want to generate as much load as possible, right? We want to see more containers, more pods spin up, right, to handle those incoming requests. So really, I'm just going to knock that down a little bit right now in terms of the demo so we can see a little bit more on the metric side in the console. All right, so I'm going to commit this to the branch. I'm going to open a pull request here. All right, so we're just going to change the version of our app and the concurrency. Just going to create the pull request. And then obviously someone else should be looking at this, someone else should be approving it in terms of a full Git workflow. But what I'm highlighting here is we're managing all this through Git in the Cloud Run revisions, the code commits, all this reverts type stuff can be handled through Git. So I'm just going to merge this pull request here. Right, and we'll hop over and verify our services being redeployed here. Right, so basically we're creating revision 2, right? We can see it's currently loading up, it's being synced. Then we're going to head over to revisions here. Right, so we can see our V2 is online. Automatically, all the traffic is redirected to it. Right, we can do some traffic splitting, but I'll show you that in the other demo. So basically, now if we go back and we just refresh our site, now we're hitting V2 of our app. In this case, it's the same, aside from the back end. Right, if we have basically one request to one container instance now. Right, and where are we going to go from that? We're going to generate some load. Right, so if you noticed on the metrics dashboard that I was initially showing you. Right, we can see our container instance count and some of the load tests that it was doing previously, right? The way I've set this up, actually, I'm going to just cover that real quick here. So on the front end here, I've set the auto scaling minimum scale to 1, right? So when we're talking about scale to 0, This is not going to be here by default. So your front end app on Cloud Run for Anthos is going to be able to scale to 0. That may be okay if if the app comes up quickly. It really depends. The first request might get lost if there's no containers running for that instance. So there's other ways to keep it warm, as you can call it, right? Where you always have at least one container instance running to serve that incoming request. I think this is a good approach, right? You can use a few of the other Google services in eventing and stuff like that to keep one request every couple of minutes, that type of stuff. So I just wanted to highlight that there.
Yeah, I think that's really use case driven, right? Like if there's an API call on your website to do maybe a store lookup or something, that's okay to wait a second or two. Yeah. And then that happens often. You can control the scale down time, like how many seconds or how many minutes. And then other use cases where, it's response, you need really responsive. You're probably going to want to keep something up and then have it just auto scale based on demand or metrics or something like that.
Yeah, 100%. And for the demo, like if we scaled it down to 0, it does take a few seconds to come up. So, having it running and knowing that it's always available when that request is coming in is kind of what I wanted to highlight there. So, but, natively Cloud Run is going to, allow you to scale to 0. You create a service, it'll scale to 0. It'll scale up if you define the maximum or if you don't define the maximum. It's really going to depend on if that's been defined as well there. So a couple different options there, but we can start to see, I'm going to zoom in here a little bit more. Right, we can start to see our container instance count has gone up a little bit there, probably a few refreshes of the page. But what I want to do is I'm going to generate some traffic here, right? So the online boutique you may have seen when I was showing you the screenshot here, we can see we have a load generator pod. I'm just going to use that. I'm going to turn it up a little bit and use our actual front end instance here. Right, we can see if I scroll up a little bit here, right, we're just going to do an exec on the on the command line for the pod, plug in our URL, kind of the user concurrency, this type of stuff, right? And what the load gen is going to do, it's going to ramp up over time. The requests are going to increase, the average and the failure rates as well, right? To simulate some predictable load on the app. It's going to come back in here and do a refresh. Usually takes a couple minutes to ramp up, but in the meantime, we can drive into this a little bit further. So this is just a good way to show. You can see on the left-hand side here, in some previous testing, we have container workloads. In some cases, from the load generator up in the 20s, right? You see them dip back down again. This is all automatic, right? And we're scaling down to 1 in our case because that's what we've defined as the minimum. And then kind of a flat line here where there was no actual traffic hitting the website overnight. And then we start to come up a little bit in the morning when there's traffic being reintroduced to the front end. All right, so I'm not going to watch that, but if we zoom in here, we should start seeing some more requests here. All right, a little bit minute behind here, but oops. There we go, we can see that.
Nice dashboard integration here. Obviously, it keeps you from having to hammer out kubectl commands and watch commands and seeing all this. It's nice to have the integration. Obviously, that's a big focus for Google, is to put all of these UI tools into GCP, the old single pane of glass story, but it's certainly starting to come true for all these different components.
Right, we can kind of see what I was talking about earlier. Right now, we're starting to scale up on the pod side. We're getting more requests. We're only having 1 container per request, right? So every time a new request comes in, we need to serve it, right? So we're starting to see more load. The auto scale is happening. In this case, it's happening on the cluster versus directly in Cloud Run managed. So we can kind of see how we can utilize our existing Anthos clusters, right, to tie everything together and utilize those resources there. I'm just going to pop this up one more time. So we're starting to see the load generators ramping up, right? We're starting to see a lot more coming up now. Right, gonna come back here. Let's do a little refresh here and see if we can get a better graph up on the page here. Yeah, we can start to see a little bit of a spike there, right? Right. So we're going from a minimum of 1, we're up to 3.5. We're going to let it run. We can come back and look at this in a few minutes and see kind of what the changes are there. Right. Other things we could do, obviously handling it all in code, but showing it here. Here's the YAML, right? We can change traffic percentages, revisions, this type of stuff, all in code. Right, so to avoid handling in here, we'll use Git workflows. Right, we can handle all the pull requests, the reverts, and collaboration through there. Right, so different revisions I'll show you in the other demos mentioned. Right, and we can have different URLs. Right, so if we wanted to still access version 1, right, to do some testing or some verification or to try to figure out some deltas between the two, we can create a URL. It's just going to append another prefix to it. So what you see here is going to have something in front of it, kind of like V1 dash online boutique type thing. So, so I'll jump back quickly to the metrics. We should see a lot more going on now. Just going to do a quick refresh here, and then we can move on to the next. Cool. Yeah, so you can see that the requests are ramping up. It takes probably a handful of minutes to really get going and push some serious requests through. But we can see, the scaling, right? And to the inverse of that, we saw the scaling down kind of in non-peak times, right, to our minimum of 1. So that's really what we're trying to highlight there with that. So we talked about, the wildcard certs, this type of stuff, and really allows the developer to, deploy their app in a very quick fashion, right? Utilize the Anthos cluster that's existing already and still having the Cloud Run visibility from the dashboard, right? We have our predefined URLs, right, with our certificates that have already been issued. So it really provides a good end-to-end flow in terms of getting access to that app securely. So I'm going to jump into the second use case. And this ties back to, being able to really create anything in terms of code or different types of languages on Cloud Run, right? So I'm going to highlight building a Docker container, right, which is a small test Python app, and show some different versions and revisions of that. I'm actually going to, I'll let the load generator run in the back end. We can go have a look at that afterwards, right? Basically what I have here is we got this Docker file, right? Just cut that out. Fucking tape. It's our simple Docker file here, our Python base and our app that's in the same directory. So I'm going to go ahead and build this. We're just going to do it as V1, pretty straightforward. Should do a hello world, but we'll add to that kind of as we do another revision here. So basically, if you're familiar with building Docker files and pushing to registries, this type of stuff. In this case, we're going to use the GCR, Google Cloud Registry, to handle the different tags and different versions of images there, but allows the developer to create their own containers, test it locally. Use Cloud Build for that if need be on the Google side. Push it up to the registry and then easily deploy that to Cloud Run. Right, we showed doing it through Anthos configuration management before, a Git workflow, and now we're going to do it through the G-Cloud command line in this case, just to show different ways to deploy a Cloud Run service. So I picked a large one by the looks of it, so sorry about that. Let's go back and look at the metrics here and see if we can see a little bit of a spike now with the load generator running a little bit more. All right. Dive in here a bit. A little bit of a lag there. There we go. Right, so we can see it's still we still have a bunch of containers running to handle those requests that are coming in. Right, the app's a little bit more busy. If we flip back, oh, I can't really do that right now, but okay, so we got our Docker container built and tagged locally. Right, I'm just going to tag it up to the GCR registry. And we'll push it up. Right, thankfully I've already pushed this up before, so we'll save the pain of watching the arrows cross the screen, which I'm sure everyone's seen enough there. But now what I want to highlight is we're going to deploy this to Cloud Run in the same fashion. So Cloud Run for Anthos, running it on the cluster. We're going to do it through the gcloud command line. Right, so basically fairly straightforward command, defining the cluster, defining which image we're pulling from the registry, location, and the platform, right? So pretty straightforward that we're using a cluster versus the managed service here. All right, so it's going to start deploying our Cloud Run service, where we pop back into our Cloud Run main dashboard here. We're going to see the services coming up, very similar to how we saw the Einland Boutique front end come up. Right, so let's dive in here. All right, this is similar. We're going to see some different requests, different type of app. Right, in this case, we are doing a true scale to zero, right? So we're not ensuring that there's always one up. It's more of a demo purposes, and it's also very, very lightweight. Suffix there, but pretty straightforward, right? We can see we have our URL that's already there, right? And to tie in a little bit to the previous use case, we'll just kind of show that we still have a secure front end here, right? A very boring hello world app, right? But to highlight that case that we've deployed an app, we did it through gcloud with our own container image in this case, and we already have a route that's working that is secured, right? So pretty quick to get that up and running on Cloud Run in the GKE cluster there. So that's what I was looking to highlight there. What I'm going to do here, so I'm going to make a quick change. Right, so here's the actual Python that we were importing when we built the Docker file. I'm just going to make a change to that so we can do another version of the app, right? Apparently that's still the same one. We'll do this way.
So, I mean, much of this is following this GitOps strategy, Hart. I mean, people are going to start checking in code and reviews, and the idea is when you check to master, a lot of these changes will get pushed out, some of the traffic shaping stuff you showed earlier.
Exactly. So we want to handle everything through Git, right? We have our audit trail and our ability to revert there and see kind of what it was beforehand, this type of stuff, and do our our pull request reviewers and this type of stuff, right? Code owners. So I'm just gonna create another image here. I've modified the Python piece to have some other wording in it, and basically we're just getting another revision of our app, right? So we still have our V1. Basically, this is going to be V2. If we look back at the code here, we can find what I was doing. Opening other windows. All right, so back here, all right, let's look at our YAML. So some of this stuff was inherent from the gcloud command, right? It was more of an automated deployment versus a declarative one, right? We specified some parameters, and obviously the goal was to get it on the cluster, right? I'm actually going to stop the load gen so we can show that, that piece here. Flip back here. So this is still going to be a second here before that's done and pushed up. Let's jump into our revisions here. So what I'm gonna do is when I get the other revision pushed up and deployed, we're gonna be able to show some traffic splitting there, right? To be able to say, a certain portion of traffic go to version 1, a certain portion of traffic go to version 2. Right. In this case, very similar example. We're just gonna create a new revision with a little bit of a change and push that service out. So let's see, it's still just about done here. We'll tag it and push it up like we did in the first example. Right, we can see the container image in our GCR container registry. We'll see any metrics on the app there. All right, let's hit this a few more times. We'll see what we're seeing in terms of that. But we can see we saw a little bit of scale up here. We had more requests coming in, right? So nice to be able to highlight that we can kind of see that in real time and right on the dashboard. Okay, so we're good with our version 1.1 image. So I'm going to tag that. Push that up to GCR. That's a new one too, so we'll have to flip back on that one. So while that's happening there, let's go back to the previous service we were showing with the online boutique. Right, so we let the load generator run for a little bit of time. Not a lot of time, but we saw, quite a bit of a scale up there. Right, so we scaled up to 8 containers there. The requests have gone down slightly. We should have a few less. It looks like Docker is taking over my machine, right? So now we're back down to our minimum of 1, right? Requests have gone down. We stopped the load generator. You can see how quickly, and that can vary how close to scale down you can get. In our case, we're scaling down to 1. We're not scaling down to 0. And this looks like it's going to take quite a while. So let's see if we can. Where are we here? Let's create another version. Actually, I'll flip over to the logs here while we're waiting. Cool. Yeah, and nice visibility here in the dashboard, right? We talked about the logging metrics that we're getting as part of the Cloud Run. We can see the request, see where it's coming from, right? All in kind of one underneath the service details, right? So everything's all in one spot. Let's see if this is not still taking a while. I can pass it over to Tim here because I think he's got some similar revision stuff going on in his.
Cool. Well, we can leave that bun in the oven and let it keep cooking up. But that's great, Hart. Thanks for that demo. I think it shows, a lot of different capabilities. And I think one of the biggest things is, developers need to build and troubleshoot this stuff, and they need the tools to do it. And being able to show some of the logs and go in and get some of that telemetry stuff without having to always, hunt through kubectl and watch it. It's really powerful. Really like vision stuff, the use cases around, canary releases and trying out stuff without having this big bang deployment, being able to kind of monitor your site when you're doing new changes, just takes a lot of the risk out of releasing software and putting it out to the world. And you can rollbacks you've covered obviously too. So cool stuff. Obviously there's a lot you can do with this. I think you've just, just given a deep dive, but at the same time, you probably just scratched the surface. There's lots you can do. So
for sure.
Okay. Let's throw things over to Tim. I will put Tim's screen on here. Everybody's still awake. Yeah, Greg's still awake. I'm still. All right. So cool. Thanks, Hart. So Tim, over to you. Let's get into the next demo.
Cool. Yeah. Thanks. I'll run through a couple of quick things just to frame up the demo and then just dive right into the demo. So some of it will overlap in terms of some of the revision stuff, but that's always good too. So I'll cover a bit of the revision pieces just while Docker continues to consume Hart's laptop there. So I'm going to cover a little bit of a CI/CD use case, pretty simplified CI/CD use case, but the idea was to kind of run through what an example of this looks like with Cloud Build in conjunction with PRs and GitHub and all the good stuff that developers are used to. So skip the introduction a little bit. I do lots of things. To Kyle's point, lots of CI/CD stuff lately, which given an operations background is a pretty interesting path for me. How Knative and Cloud Run simplify the CI/CD pipeline. The only thing I wanted to do is kind of just highlight this statement of, where does this fit into the CI/CD pieces and kind of how does this get simplified? And, the reality of it is there's lots of ways to handle this, right? So Hart was showing a use case with Anthos config management and rolling out changes through a YAML manifest, a straight up Knative YAML manifest. In this one here, I'm going to leverage Cloud Build and Git for the entirety of this. So the idea being is to abstract the YAMLs completely from the workflow. So quite literally, the only YAML files we're dealing with at this point are our pipeline YAMLs or the Cloud Build YAMLs, which generally speaking are a little bit more comfortable from a developer perspective, something that we're used to, where we don't really have to think about the operational components to the same degree. And so the idea behind Knative and Cloud Run really removing some of that, or abstracting some of that, I should say, doesn't remove it. And really handling some of the things like revision control, rollback, and traffic management in a much more seamless way. So I'll dive right in. Where does this really sit? Just a quick sort of frame up. The reality of it is the use case here is, Kubernetes is, a great platform. It's done wonders for microservices in general, but at the same time, where does it go from here to help the developer experience? And, I kind of look at Knative and Cloud Run as that way to start to think about having developers focus on, the task at hand, which is really application deployment. And in the Kubernetes world, like kind of showing here, developers still got to build Docker images, they still got to upload images, still got to deploy a service, expose it, et cetera, et cetera. And so we're going to enter into the whole, Cloud Run and traffic management. I'm going to touch upon some of the revision stuff that Hart was going through as well as a part of the CI/CD workflow with a quick demo app as well. And just to frame up the actual demo itself. So the idea being is to have a pretty straightforward CI/CD pipeline completely in Cloud Build. So, it's pretty simple. Whether or not this is, completely maps to a use case that you might have is something that can be kind of discussed and worked through. But, the idea here is we've got a repository that's going to host our source code. It's a simple web app that we're going to host in there, and we're going to make some changes to it. The idea being is we've got the Cloud Build app for GitHub configured for our repository. And essentially that's going to handle the quote unquote webhook functionality from a GitHub standpoint and trigger off our builds inside of Cloud Build. And I'm going to show you two different parts of the pipeline, one being a PR based pipeline. So every time a PR is issued, we're going to do a quick build of the container, nothing more, nothing less, just to kind of showcase the ability to use that GitHub app to submit check status to our pipeline or to our Git PR. And the idea being is to do, enhanced tests and, any of the other things that we might want to do. In our case here, we're just going to do a straight up build and just make sure it builds successfully. And as long as that passes, we can merge the pull request. Once this hits master, we're going to go and deploy the actual application or the new revision into Cloud Run and Anthos. So I promised a quick couple of slides, so I'm going to dive right into the demo.
Nice. The quickest set of slides leading into the demo. I love it. Your award is on the way.
Perfect. Send me some lunch. I'm tired of cooking.
The community appreciates it. Maybe up your text in the bottom a little bit.
Yeah. Let me do that. There we go. Okay, so I did want to showcase, just while Hart was talking there, about the use case around online boutique and maybe not having that scale to zero based off of keeping that hot. One of the things I wanted to show is I've got the app kind of pre-deployed because I kind of wanted to show what scale to zero looked like in the Cloud Run sense. And so the idea here is we can see we've got a version of our application, a revision of this random Giphy app running. It's online. 100% of the traffic is headed towards the latest revision. And I wanted to show sort of that linkage again, similar to what Hart showed around the linkage to Kubernetes, right? So, the real value in this use case is tightly coupling services to any of the backend services like Hart was showing. In this particular demo, I don't really have any backend services, so we're just going to show the front end part of this. The scale to zero here is we're seeing no pods in here. There's no traffic against this. I didn't throw a load generator in here. The idea being is to truly show sort of the scale to zero, or in this case, we're starting at zero. I'm just going to throw this on a quick watch here. So we'll throw that on a quick watch, and then we'll just do a quick couple of examples here. And the idea here is I've got this configured to show us 90s Giphies. I'm a 90s fan, so I chose 90s as the starting point. Apologies if anything weird comes up, because this is truly random. But let's roll the dice. Let's do a refresh here. And we can see the first time we run this, we've got a little bit of a delay. And this is kind of what Hart was talking about, where that initial request is kind of cold, because right now we don't have anything actually running in there. There's no pods running in there, that sort of thing. And so the idea is now we've got a new Giphy. I'm not quite sure what that means. Maybe I don't know the 90s as well as I thought I did. But regardless, we can go in here back to our console, and we can see that we've got that pod spun up. And so the idea is now that application is warm, that pod is warm, and as we're doing refreshes, it's quite quick because we don't have to spin up new pods to handle that workload. And then effectively what we're going to see is we're going to start to see, as we stop pushing requests to this container, that they're just simply going to drop, and we'll start to terminate this pod. So yeah, a quick example of what that scale to zero looks like, and kind of a showcase that we are running this on our GK cluster. So I will head over and show you the Git repo for a quick sec, and then we'll do the quick demo on CI/CD, and then we'll move this along, and I'll get Greg up to tee up real quick after this one. So I wanted to kind of showcase a couple of things inside this main repo. The idea is I wanted to split up the sort of difference between when we roll out to master. And so the idea is I've got Cloud Build and the Cloud Build app configured to target this Cloud Build others Cloud Build file. And this is where I was saying it's nothing more than just a straight up Docker build to kind of test that we can build the container successfully. If this fails for whatever reason, then effectively that is going to die, and the check is going to fail, and our PR would be blocked if we chose to configure Git in this way that it would block. But ultimately, it serves as sort of the use case of I could put a whole bunch of other things in here. So, we've done demos in the past on things like ephemeral clusters and spinning up ephemeral environments to go test a particular rollout. This could be another cloud build, or it could be another revision or something like that. But ultimately, I wanted to keep it simple for the demo. And then we'll head back over and I'll show you what is the Cloud Build master file. And the Cloud Build master file is doing a couple of things for us. One is it's doing the Docker build, so it's going to do a fresh build and a push into GCR. And once it does the push into GCR, we're going to go do a gcloud deploy in the pipeline, very similar to what Hart was showing, just burying this into a cloud build pipeline. And we can see that we're targeting a cluster, and by targeting a cluster, this signifies that we're not running in managed Cloud Run. This is Cloud Run for Anthos against this GK cluster instead of going against the managed instance or managed version of this. So like I said, pretty simple workflow, pretty simple pipeline, but let's go ahead and make some changes. So one of my favorite things, probably because my kids are addicted to watching these kind of videos, is fail videos. So I'm going to go ahead and change this app to fails. And the idea here is we'll go and we'll change the title that we see on the web page, and then we'll change the tag search. So the idea here, and those who have seen some of my demos, I use this app quite a bit. The idea being, we're just going to change the tag. We're just going to change what we're going to look for against the Giphy API. Contrary to Hart, we're going to do this to a PR because I don't want to do it to master. But the idea here is we're going to change this over to fails. I'm going to put a commit message in here, unlike Kyle. We'll put in one of your commit messages here in the description, Kyle.
I'll do on a great developers check into master, right? Let's be honest. So
we'll go and propose the changes. Basically, it's going to create a new branch. Prompt this here for the pull request. We'll go and create the pull request. Similar to Hart, I'm going to merge my own. Obviously not the real use case, but the idea here was to kind of showcase what this looks like with a check-in here. And this is our Cloud Build GitHub app that's getting inserted into the mix here. And so we can do branch protection from a Git standpoint and make this a required check. But the biggest thing for me is we're offloading this, and we're offloading this into Cloud Build. And the idea behind Cloud Build here is this is going to take care of all of the build processes or anything else we include in that pipeline. And so in our case, we've got this triggered off of a PR. Anytime a PR lands into our Git repo, we're going to go ahead and build the container. As long as this succeeds, the pipeline will succeed, get marked as green, which we're seeing right now. So with a green checkbox, we have that translated back into GitHub. One of the things I do like is this, kind of green checkbox kind of showing up here now right at the top. So I know this succeeded. I can see all checks that passed here. I can have a look. I can dive into the details. And since I know this succeeded, I can, obviously, if I wanted to review it, I could review it just like any other pull request. But we're going to go ahead and merge this. Now, once we merge it, we're going to kick off another pipeline. And so we're going to go back into our history here in Cloud Build, and we're going to see another instance of Cloud Build trigger based off a new commit into master, based off of our PR merge. And we can see here a ref is master. We can see the trigger name, which I named Giphy master. And we can go in and see some of the details, obviously similar to what we did on the PR workflow. This time we're actually doing the build and a push into GCR, and we're going to go and actually do the deployment to Cloud Run. As long as the demo gods are with us, this should all be successful. We'll deploy a new revision, and everything should be good. And it looks like, so far, they are with us. So fingers crossed that they stay that way. We have green checkboxes everywhere.
Thank you.
Now, because this... Yeah, exactly. Thank you, Cloud Build. The nice thing is, so all of the stuff from a PR standpoint makes sense. We've got the checkbox beside the check that passed for the PR. Now, if we go back into the code and we have a look at master, we also get a nice visual here for the last commit into master. And this is this checkbox here, which is a different trigger. This is the master trigger. So this is kind of the inverse side of the PR. This is our merge into master that's signifying is good. So effectively, without really leaving GitHub, we kind of know everything is in good shape. And this is, to me, part of the power here is, not dealing with YAML manifests, effectively being comfortable from a Git standpoint and development workflow standpoint. This all feels natural. I don't have to go and edit any YAML files. I don't have to care about how it's going to get deployed to the cluster. I just point it at Cloud Run and let Cloud Run handle the rest. Now, what I'll show you here is this actual deployment. So I'm going to close this now. We see that one terminating. And this is kind of the end of the CLI portion of the demo, which is, again, part of the benefit here. I wanted to purposely kind of stay away from CLI here. And the idea here, I'll go and do a refresh. We see our new revision. One of the things I did is I configured this whole workflow to not automatically tag all the traffic to the latest revision, because I did want to kind of showcase and kind of hammer home some of the idea of traffic management. So if we go, this one will be cold again, but that's fine. We can fire this up. It only takes a couple of seconds for this particular pod to fire up. We can see here, we've got 90s Giphy still. We're still on the 90s release. So let's go ahead and switch ourselves over to the new release.
Can you control plus a little bit on that, Tim, on the GC screen?
Yeah, sorry about that. I thought I did already.
The Giphies are being very friendly to us today. We've got some doozies in customer demo. If we could do a whole event on, that one.
Yeah, thank goodness. Demo gods are with us again, right? And actually, maybe what I'll do just to showcase that traffic management capability here is I'll split the traffic. So I'll send 50% of our traffic to this new release. Sending 50% of the traffic to the new release will now have Cloud Run go and configure all the Istio stuff in the back end. So Kyle made mention to a bunch of this stuff being built on Istio. So all this traffic management, traffic redirection, fault injection stuff, everything is all Istio functionality that's been leveraged to make all of this possible. And so if we start heading over here and drive traffic to here, we'll get about 50% of our requests here will now show a fails Giphy versus a 90s Giphy. Apparently s'mores were popular in the 90s. And there was a fails Giphy there. So the idea here is about 50% of our requests here are going to head over to the fails revision, and about 50% of our requests are going to head over to the 90s revision. And like I said, the benefit here is all of this is done with very little interaction with the typical sort of Kubernetes manifests. I could, and that's a big part of what Hart was showing, is I can interact with the manifest directly or put them into another system like ACM, which Hart did, or I can go and I can manage them just from the Cloud Run console here. But the traffic flow entirely is through our cluster, not through GCP. So this is a management and control plane conversation, less of the actual sort of, things hosted in cloud in this particular instance. So I'm going to drive 100% of the traffic over to the new release. And very quick change here. All of our traffic is now headed to the new fails release. So nothing here should now hit 90s. We're going to be in fails entirely. And, effectively we're in good shape. And some of these are doozies. I like them. So one of the things that I wanted to highlight from a CI/CD and sort of developer experience side of things with Cloud Run is not only are we abstracting a bunch of this stuff, we're doing things like managing concurrency. We can add environment vars, we can load up secrets and config maps. So this is another important difference with Cloud Run for Anthos versus the managed offering of Cloud Run, is by tying this natively to Kubernetes, I can leverage some of the Kubernetes principles and make them available to Cloud Run. So, Hart showed the ability to have backend services that are referenced by a front-end service sitting in Cloud Run. Another option here that we can see is we can actually load up Kubernetes secrets or config maps into our Cloud Run pods, just like we would any other Kubernetes pods. And kind of the last thing I wanted to kind of highlight here is, outside of the CI/CD workflow, part of my concern has always been the rollback sort of thing, right? And, rollback tends to be tough. Testing workloads, that sort of stuff tends to be tough. So there's two things I wanted to kind of show here. One is, maybe it's obvious, maybe it's not, but traffic management works both ways, right? So I can go and I can pick a revision that I want to go back to. By the way, these are all off of commit SHAs. So I've named my prefix based off of the commit SHAs. So 417.1437 here relates back to the commit SHA that the master merge was related to. So I can go and send 100% of that traffic back into the 90s workload that I know is sitting there for 90s. I could have labeled these, by the way, to make this a little bit easier, but again, for simplification's sake, I left it pretty straightforward. And we'll do a couple of refreshes here. Again, we're a cold start here because by the time we got to this, the 90s pod scaled down. And that's about a 1 minute time frame, by the way. And so now we're back to 90s. Oh boy, there we go. We're definitely 90s. And so the last thing I kind of wanted to showcase that is a little bit of an interesting use case. I like it for the testing use cases. And one of the things that Hart was showing here was not only are we able to do some default stuff around URL management and custom domain mapping, we're taking this to a full-on Istio backend gateway that does HTTPS redirection, which is how we're handling this to get valid certificates. So everything here looks really, really good from a quote-unquote prod standpoint. But one of the things we might want to do is just actually test the release. So we can go here and we can test releases by adding revision URLs. And I'm going to add a fails revision URL to this particular release. And the revision URL will now spin up a new URL that'll answer on a particular revision. And even though we're not actually driving any real traffic to it, we get presented with another custom URL, and that custom URL will drive us to the revision that we really care about. So if we want to test a particular release without managing traffic, without sending actual end users to it, we can easily add a revision tag like this and get a specific URL that's generated for us by Cloud Run. So all the Istio magic is done for us. I quite literally didn't have to do anything as it pertains to Istio.
You just
didn't have to touch a YAML file.
You just eliminated back in the day an entire rack of gear that was called CAT for customer acceptance testing, right? Now it's like, here, go here, look at your site, let me know if it's good, and I'll push it out. So that's pretty cool because we used to build full environments for those type of use cases.
Yep, exactly. And I mean, the options are endless. Like whatever, test ABC or whatever, you wanted to set for your revision URLs, these are all possible. We can add, revision URLs that make sense to drive teams to particular releases. And so, like I said, very purposely, the CI/CD pipeline in this case doesn't automatically drive traffic to the latest version to kind of showcase this, where we might want to just release it and then set revision tags like this to drive our testers to it and make sure everything's good, and then gradually move traffic over to it. And that's what I got for you. So happy to answer questions at the end of this. Like I said, the idea was to kind of showcase a little bit of an alternative side of this use case, really around not managing YAML and really showing that abstraction capability.
Nice. Awesome. That's great, Tim. So Kubernetes doesn't have to be hard, people. There's lots of clicking and putting numbers from 1 to 0 to 100. So that's awesome. That makes things really easy. You're not always. I think we always advocate for get out of the clusters a little bit more and start to drive this stuff through automation. Fingers in clusters that are in production are generally a road to outages and ruined Sunday nights and things like that. So that was really awesome. All right, Greg, you are up. I guess I can run the slides here for you.
Thank you, Karen.
And then we will get into the demo. And then I see we've got Ahmet also has arrived, so we'll get him in on this thing next. So glad to see everybody sticking around. Hope the content's hitting home for you. So over to you, Greg. Take it away.
Okay, so for this section, that would be a lot more manual than what Tim just showed you. Tim showed all the full-fledged pipeline, so I will go more into under the hood how Anthos Service Mesh can be configured. So, Kyle, if you can.
Cool.
Go to
I think people like to see what's underneath the hood, also. So
exactly.
Yeah.
So yes. So my focus Arctiq, Kubernetes automation, and I'm trying to think back of when I was a software development manager, how I could have used all those technologies. So that's what I do. Next slide, please. Okay, so I'm sure a lot of you guys know what Service Mesh is about, but just as a refresher, so this is what you see on the screen is like the typical Kubernetes diagram with different nodes. So those nodes could be even different clusters, but nodes are typically machines and they host different pods. Each pod has its own networking system and its own storage system. So the deployment is where your workload lives. So now what a service mesh is, it's a new capability that is unlocked when you inject a man in the middle between the deployment and the networking. So Kyle, if you can go next. Kyle, thank you.
Yeah.
No,
just a bit of a delay. So
okay, cool. So here you see this man on the middle is a proxy in the case of Istio, because Anthos Service Mesh is Istio. It's a flavor of Istio. So this proxy is Envoy. It's a very modern proxy written in Go. And so the good thing with that is by having all this series of proxies that will manage the communication between the workload and the network, we can have a central control plane that will unlock a lot of new new possibilities that we'll be exploring. Next slide, please.
Yep.
Okay, so for example, by having all this abstraction on top of Kubernetes, we can have more control on the traffic. We can also securize the communication inter-pod or inter-services using encryption, end-to-end encryption. We can also extend this mesh to add some elements that are outside of the cluster. So we can have a service in one cluster communicating with a service in another cluster. And the last thing that is very important is now we can observe exactly what happens between all those microservices. We can get measure around latency, availability, and all those kind of things. I think in the next slide we'll see the okay. So yeah. So we will focus on that. So observability, that's giving us new metrics, and those new metrics, the development team can use them to be a bit more conscious and manage the downtime. So that's what I think we'll start the demo. I will show you that in real life through the dashboard.
All right. Thanks, Greg. Let's do it. Nice quick intro. Couple slides. Perfect. So I'll throw the screen over to you, and you're off.
Yeah. Okay. So here, what we see is the Anthos dashboard, but behind the scene, everything starts with a cluster, a GKE cluster. So you see, this is the cluster I will be using. In order to use the Anthos Service Mesh, I will have to provide a label, a mesh ID. So that means all the services on this cluster will be automatically part of the mesh. So while my colleagues were doing their demo, I installed ASM using an operator in the background. So you see it's using istio-ctl, so the same control tool that the regular Istio is using. There's just a specific profile called ASM. So when I'm doing that, it's creating all the base components, the pilots, ingress gateways, everything. And this will create a new namespace called Istio system to hold all the service mesh components. So the next thing I've did here is to create a namespace to isolate my online boutique. I will be using the same demo as Hart. So this namespace, then in order to enable the sidecar injection, I have to add this specific label, Istio injection enable, to this namespace. And now every deployment in this namespace will be automatically added, augmented with a sidecar. Next step here is to apply directly the manifest from the Git repository. So here we can see that all the deployments and services for all the 10 or 12 microservices gets created. And finally, this manifest will install all the Istio components. Because by default, the online boutique can work without Istio, but this one will allow us to leverage the front-end gateway, the Istio gateway. Then to avoid any kind of mistakes here, I'm deleting the service that is not using Istio, because Istio is available through a regular load balancer or through the Istio gateway. Okay, so now let's see what's the results here. So here we have this online boutique that is working as you would expect. And in the Anthos Service Mesh, here we can see all the services. So this black dot means I don't have an SLO yet, so I'm not measuring performance. That's something we'll be fixing soon. We got some metrics, the request rate, request per second, error rate, latency, 50%, 99%. And there's an experimental feature here or beta feature, sorry, that will allow us to learn a bit more about this online boutique. And all this thing is generated dynamically.
Yeah, I think people that are.
Yep.
I'm just going to add, Greg, people that are familiar with the open source toolkits like Kiali and Jaeger and Grafana, you start to see what Google's doing is they're taking a lot of those capabilities and then back to the point we made earlier is putting them into the GCP console. So you're not having to run all these services yourself and having to flip between different tools. You can do it all through one kind of console and one integrated platform, get to your logs. So really nice integration that they're adding with Anthos Service Mesh.
Exactly, it's kind of neat, and we can see exactly the request per second coming from each source. So it's giving us a bit more details on what's going on. Also, there's another feature I can show you. If I can compare here 2 versions of this service mesh if it's working, okay. I don't know, this is still beta. Okay, cool. So here we can see, how was the mesh yesterday when I was doing my test versus how they were this morning. And all of that is based on real traffic. So you see that this morning I've been adding a different workload and the connection is a bit different. That could also be useful to see exactly what the consequences are of the real life traffic on the website. Okay, so now let's go back to this table view, and because it's a boutique and the boutique is made to make money, we want to make sure that it stays available, and the dev will be the first one to know if there is a problem. So to do so, I can create an SLO. So an SLO is a service level objective. It's based on this SLI, the service level indicator, which is a measure of how good your service is. So you have typically 2 main metrics, availability and latency. So here I will use availability on a Windows-based period. And I would say that I want 99% of good periods. And my performance goal here will be also 99% over a day. So yes, here I've been a bit ambitious because I've been breaking the cluster before. So the error budget is already exceeded. So I will change that, turn it a bit down, and that will work better. So let's say 95%. Oh, I should have changed the title. But yes, here you see we still have some error budget. So basically, we are provisioning period of downtime that are acceptable. Now, another cool feature I can add here is I can also build an alert on top of that to get a message when the burn rate exceeds a certain threshold. So here I can look back the 5 previous minutes and making sure that the rate is below a threshold. And here we have 42. I'm not sure 0.42 is the answer in this particular case. It's probably an answer to something else. So I'll do 0.1. And now I'm adding a notification channel because I would like to receive a Slack alert if the availability budget starts getting burned. So here you can see we can also add a personalized Markdown-based messaging for the recipients. Okay, saving that. So I could do the same thing for.
Nice, that's pretty handy. We did. We used to do a lot of chat ops demos and integrations through Slack and things like that. So it's pretty cool that you can get the alerting through there, and then people could build scripting and stuff like that to start to do repair and remediation or page someone, things like that. You know, Slack seems to be the way that we all communicate. So it's nice to have those little plugins for the API.
Yeah, exactly. It's a good good way for the devs to know when something is off. So we'll have to git a few, and then we'll see here a green dot coming. So in the meantime, I will also work on simulating another deployment. So doing that right now. So in order to do some, because we'll be doing some traffic shaping. To do some traffic shaping, we need to tag properly our deployments with a specific version. So here it's almost the vanilla frontend, except that I've added the v1 suffix here, and also I'm adding this tag, and you will see later why. So I'm applying this one. I had to rename this frontend because the labels are immutable. So I'm gonna apply this one and then delete the original one just after. And now I want to make sure that my service is still working, and it's not working yet because my new deployment is not ready. Yes, one is running. So the sidecar envoy is running, but not the payload yet. And now it should be okay. Okay, and the boutique is back online. So the same one, same workload, same thing. Now, next step will be to create a new deployment with a different version of the code. So here, I'm creating the v2 with the proper labels. And as you can see here, I've customized this front-end application to add a different color to the subnav. Okay, I apply that. And when I'm applying it by default, because this is managed by an Istio proxy, those two deployments will be equally balanced. So we should see a 50-50 split. And the pods are up, obviously. So here, the front-end v2 is still creating. So the sidecar has been created. Now we're waiting for the workload, and the workload is up. And now, if I'm refreshing, I should see. Yes. Okay. So here you see I'm hitting. So the distribution should be 50-50 because I've not specified anything. Okay. So here we can see both deployments working. Now we can play a bit with our application and try to poke hole into it to see if we are changing, introducing delays, how the application is reacting. So for example, here, I will add a fixed delay of 7 seconds for the recommendation service. And that should slow down my page in 50% of the cases. So I'm gonna try this one. And yeah, this is the recommendation system. So this part, the main page depends on that. So the main page will slow down. Yes, and here you see I'm hitting the 7-second delay. So that can allow us to see if we should implement a circuit breaker or those kind of mechanism in order to keep the speed acceptable. Okay, so it's working. I will delete that because it's kind of annoying. And I will now inject some errors. So here we could pretend that the currency service has a bug, and in 10% of the request, it will give us a 500 error. And let's see how our application is ending that. Oh, okay, 10%, I got directly the error. So you see the front end is giving errors. Both versions. Now sometimes it will be working, sometimes it will be failing. I don't know if I can go through and add something to the cart. Yeah, no, it's fitting here. So here we can see that the application is not properly handling when the conversion service is not up. And so typically in this case, we could, if I was a developer in this team, I could maybe think of using a cache or some other kind of mechanism to protect against that, because the currency are not generally very time sensitive for this kind of boutique. So now we could do something else in terms of traffic shaping. We could also change the weight, how one service is, how one deployment is getting traffic versus the other. So by doing that, here you remember I said I've added a label to our deployments. So those labels are used in an Istio destination rule to create a subset. So this is how I can say I have a subset V1 and a subset V2. Subset V1 is the first version with version V1, and same for V2. And now those subsets can be used in a virtual service. And I can say the old version will only be getting 10%, and the new version will be getting 90%. So let's apply this. Okay. Oh, and I should also remove the fault injection. Let me delete that.
Yeah, I always, when I see these demos, it always reminds me of the power for like a QA department to take advantage of a lot of this stuff. It was always a QA team reaching out to someone on the ops team to, make changes, update code, update releases. This, with the right amount of access and giving them the right Git access to wrangle the YAML. You could automate a lot of this stuff, and then the QA team can really, go at the velocity that they want to be able to go at. They can do other integrations, test other services. So that's just one use case, obviously, but it certainly opens a lot of stuff up for faster testing.
Absolutely. And so now we see we are mostly hitting the new version. So 90% of the case, this is what we were expecting. And what can I see here? I see that my Slack channel is getting an alert. So here, I got an alert because my burn down rate has exploded and it's above the threshold. Okay. Okay, going back to this demo. So now let's say we want to deploy, speaking of QA, we want to give the QA a way to test before the rest of the company. So a way we could use is we could direct this traffic using this kind of match patterns. So here, I will be able to match my user agent header, and based on that, I will obtain the new version of the website, and everyone else will get the V1. Okay, so let's try this one. So like I said, everyone else is supposed to get the V1, so I should see only black now. And my QA friend, I will say, hey, tweak your user agent a bit and use a Greg user agent. And you see, as soon as I'm using the Greg user agent, I will get 100% of the new website. So I can test everything I want to test. And if I'm going back to normal, I should see back to the regular website. Okay, so now sometimes the new service we have deployed is crashing in production, and it has not crashed in every lesser environment, obviously, because otherwise it would have been caught. What do we do? So the obvious thing would be, okay, so we roll back Okay, but if you roll back, how would be able to reproduce and understand exactly what is going on and why we didn't catch the issue in the first place? Because obviously we don't have the right test case for that. So there's a feature very interesting we can use. It's called mirroring. So I will show you that. So now let's assume the new version has a bug. And I want to know more about the traffic that is going on. So the way of doing that, use the mirror. And so you can see that the regular destination is the old website, the old version of the application with a weight of 100, but also I'm mirroring to the V2 with 100%. So in this case, the new version will receive 100% of all the calls, but the response will be discarded. So, and for visibility, I won't apply this one. I will cheat a bit, and instead of giving a V2, I will create another service that will make things easier. So this service is just a fake HTTP service. It's a Python script that will just display in the logs whatever request it's receiving. That will make things a bit more obvious. So to do that, I'm applying this HTTP bin, which is a new service, and then my mirroring will become, instead of having front-end V2, I will direct to a totally different service. You could also imagine that this host could be a totally different cluster, even, yeah, maybe the dev machine itself or whatever, but this host will receive 100% of the traffic. So I'm applying it, and I want to see the pods, get pod, sorry about that, get pods, so we want HTTP bin, and we want to see logs, this one, HTTP bin -f, and we are opening the logs. Now I'm gonna go to the website and click some stuff there, place an order. And when I'm going back, you can see that this new HTTP bin, so even if the website was fully functioning as usual, I can place order everything, nothing is visible from the public, but here I can intercept and see exactly all the payloads. You can see the checkout and everything. So now that's it for me, for my YAML tweaking. We can go back to the Anthos Service Mesh and see what our SLAs and SLOs are saying. Okay, let's see what is Slack saying. Okay, Slack is still giving an alert. So I will also receive a Slack alert when the burn down rate is back to normal.
Cool. That's awesome, Greg. Thanks for that demo, man.
Thank you. Okay, so yeah, if you have 1 minute or two, if I can show you the value here. So see, here we have an alert. So we see that one alert has fired. You see the error. And then here we could get the details. And we see that even if you got this alert, we are still within the budget. That's the important part, because as a developer, I want to be able to fix the problem before I run into trouble and I start exceeding the SLA and there are business consequences to this mistake.
Cool. Yeah. That's an interesting way to stand up to your contracts that you have with some of your service provider or something like that, right? Everything's driven by SLA, SLO. Being able to prove that you're meeting those objectives is very important. All right, Greg. Well, thanks for the demo, and I think we're at the last part now. So, with all good things, we bring a special guest to the table at these events. And I think I had you muted, Ahmet, so I'll unmute you. So yeah, Ahmet's with us from Google, developer advocate, who I think he didn't wear his I Love Cloud Run shirt today. It was in the wash, but But knowing him, he does a lot of stuff around Cloud Run and Kubernetes and Knative and things like that. So thought it would be cool to bring you in, Ahmet, and talk about just some of the stuff we demoed today. But also, I know you spend a lot of time with customers, and you hear about kind of real world problems and what they do. So maybe just give a quick background of yourself and what you kind of work on and what excites you and some of the cool stuff you're seeing today. And then we can dive in and talk a little bit tech. And I think we could do a little demo. You might have a little demo ready for us. So that's awesome. So thanks for joining us.
Hey, yeah, it's great to be here, Kyle. Thanks for inviting.
Oh, I think you might be.
Am I muted? All right. Yeah.
No, you're good.
Yeah. So I think, I don't know, like when I look at Cloud Run and how people use it, as you all said, we have two different flavors of Cloud Run. There's Cloud Run fully managed. There's Cloud Run for Anthos. We really see a huge variety of use cases on the field. Like there are people who just want to like fulfill the serverless promise. Like they want to come in and they want to like spend the minimum amount of money possible and run their website, all the way from here to actually, as you've actually showed in the demos, like, like migrating some of my services from Kubernetes to Knative so I can have better Kubernetes experience. So what I've been hammering on lately is like Knative, if you really think about it, it's just better version of Kubernetes. Like it runs on Kubernetes, but it just makes your Kubernetes better, right? Like if you really think about it, you get better even load balancing. We tend to think Kubernetes does load balancing for us, but does it really? So like when you, let's say, are running gRPC without a mesh mode or something like that, without Istio, you actually don't get per RPC load balancing. And that might be an issue for a lot of people. Like you'll see your pods unevenly load balanced. So like you can go from there all the way to auto scaling. Like, what I tend to like discuss auto scaling with people and like just to see how much they know about Kubernetes auto scaling. And like, as I say, how do you think Kubernetes like auto scales? Like, they say, yeah, there's like CPU metrics, memory metrics. But I'm like, let's say you got a spiky traffic, like you just, something happened and suddenly you're getting 1,000 requests per second, but you only have like 1 or 2 pods around and you can't handle that. So what happens? Well, what happens is before Kubernetes can realize there's a need for scale up, your container crashes. Right? So your service is already broken before Kubernetes could even do anything about it. So that's why Cloud Run is actually that piece that brings us that serverless capabilities that we didn't have. Like it can act as a meat shield in front of my requests. It can handle a lot of load. And while it scales the pods in the background, it'll just hold on to the requests. Sounds simple, but Kubernetes doesn't do that. And Kubernetes doesn't try to do that. And that's why we need these tools like Knative. And this is usually like when I talk about these sort of features, it really resonates with a lot of Kubernetes developers. Like, yes, Kubernetes does a lot of things pretty well, but Kubernetes doesn't want to also go that last mile, right? That last mile of opinionated building blocks that comes from Knative. And like, if you really want to build a PaaS on top of Knative, you can still go do that. But for a lot of Kubernetes users, this is already a huge improvement, right? So that's what I'm seeing.
Yeah, I agree. I think it's interesting, and I think it's something that will keep Kubernetes in a strong place, is sticking to those primitives, right? Like do what you do well. You're a great scheduler. You do certain things well. Everything's API driven, declarative, and then it allows people to build on top of the platform without having to build proprietary integrations. And I think one of Google's big focus is to stay Kubernetes native, right? Stay close to the native features and then build value up the stack. So you've seen, we talk about ACM a lot. We talked about Service Mesh today. I love the features of Cloud Run and Knative that really brings that developer experience to the table. Yeah. So, I mean, you being a developer, I know one of your, you've got a project at kubectx that I saw got lots of traction. I've seen people saying it saves them a ton of time. We're all dealing with many different clusters. We're switching between contexts and things like that. So what prompted you to write that? What's the story behind that? And love the fact that it's open source. And apparently by the picture in your GitHub repo, you like poutine too. So another fun fact. I think that's French fries. What it looks like.
That's churros. That's churros. Yeah. That's churros in my profile picture. So okay. I was going to say, so I've been in the container space for a pretty long time now. Like I've been a Docker maintainer around 2015 at Microsoft, and I've been in the container space for far too long, and I've done quite a lot of projects. But funny enough, the most popular project that I'm known with is just a 200-line bash script That's what kubectx is. People hate bash, but you know what? It saves us a lot of time. So that's what it is. Nowadays, I'm actually focusing on a lot of like Cloud Run related tooling and projects. Part of my job, I'm a developer advocate. I defend developers inside the company, but I also like think about how can developers have a better time. I can do a few things at Google, like I can say, hey, let's add this feature, that feature. But I also can make the world better for open source developers, like for Knative users, for Kubernetes users. And that's what I've been trying to do. Like I've been running projects like kubectl plugin manager, or little tool that lets you run kubectl commands much faster. Like I have this kubectl aliases repository. There's like thousands of kubectl aliases that are automatically generated. So I see myself as like this person who potentially can help Kubernetes operators a little bit better.
Cool. That's awesome. And one of the things I know we talked about in the past is we're doing a lot of work on, customers moving to Kubernetes. So we went through this evolution where I think there was a lot of thought of let's move everything to Kubernetes that we can. And now we're being way more meaningful. Like if there's a reason for it to run on a VM, great. If there's a reason to move it to a service, then let's focus on that. We're seeing a lot of customers move from other Kubernetes platforms. Like people started out with Docker and then they needed a real orchestrator. We've seen a lot of people, they were Cloud Foundry very early, and now they're kind of looking to re-platform. We've got tools like KF and stuff like that. And what is your I guess a lot of the things where this started this developer experience, I look at like Heroku build packs and things like that, and how build packs used to work. And I think the plan is for you to do a little build pack demo for us. But do you want to talk a little bit about the different options of just developers deploying applications? So you think some people start with just kube apply, and then people look at Helm, and then they look at a pipeline. But what's the build packs seem to be jumping up again? I knew Google's putting some more work in this space. So what's your take on that? And then maybe we can jump into the demo and give us a little view of what it looks like.
Absolutely. So I think what really excites me about Cloud Run and Knative is, Knative is, I tend to think that's the infrastructure piece behind it. But if you look at the Cloud Run fully managed, the serverless version that runs on Google's infrastructure, right? Like that really excites me a lot because I know a little bit about containers and I can just run things there. But there is still that price of admission, right? You need to know containers. And the build packs project, the cloud native build packs project, eliminates that requirement. I can go back to 2008. I was in high school the first time I tried Heroku, by the way. I was amazed. I was like, wow, I can run things on cloud now. I think back in there was also App Engine. I tried App Engine a year later. I was amazed. I deploy this thing and that's someone else's problem to run the machines. That was a revolutionary to me. So that's why I actually still do work on Cloud Run. When I realized we're doing something like Cloud Run, I'm on it already. I'm gonna work on this thing for the next 2 years. That's really what gets me excited in terms of developer experience. So let me share my screen actually. All right.
Yeah, let me put you up here.
Yeah. So as you can see, There I put this. I'm gonna show you just a couple slides here, not a lot. So we have this journey that we want to encapsulate as source to URL experience, right? This is for a lot of developers. This is exactly what they're waiting for. When they think of serverless, they want to write a little bit of piece of code and glue a few things together, right? They're not trying to deploy their entire infrastructure on serverless potentially, and that's okay. So when they're trying to develop that and deploy that little app, they go from source code, which they have control over. They want to go to a URL, which they can send to their customers or visitors, right? So how do we get there? There are a lot of ways. But mainly what we're seeing that, for a lot of people who don't know containers, that container image part is really the pure price of admission, right? You get container image, and from there, you can actually go to Kubernetes, GK, and Cloud Run, whatever. So when I look at this experience, let's parse this out. You write an application source code. Let's say you write a Python app. It has a main function, right? You have a little HTTP server around it. You write a Docker file. You put it in a container. If you have a function, if you're coming from Lambda or Fastland, and let's say you want to run this on Kubernetes, what are you going to do? You're going to probably have to convert that to a full-fledged application, or you're going to use a functions as a service framework, which is another thing that you have to manage if you install that. And you're still writing Docker files potentially to convert something into a container image, right? So that's the way I see it is that red part in the middle that really bothers me a lot, and that's why we have been investing in this technology called Cloud Native Build Packs. So if I'm the developer, I still write my application, or I still write that little Lambda function, like that 2-line function potentially. And then I can just use build packs, and I don't have to worry about the rest of it. The container image gets built and pushed for me. So all of this, like using the build packs, what I mean is, like, this is one command. Like, I don't have to do anything else. And that's not a complicated command. This is like Docker build, basically. So, the thing that makes this possible is this thing called build packs. If you have used Heroku in the past or Cloud Foundry in the past, you probably know what build packs are. Build packs, let us convert our application source code into container images so we can run them on container runtimes, right? This is a CNCF project, just like Kubernetes and everything else. There's nothing interesting here. Build packs provide actually several opinionated build packs. Like, they have Heroku's build packs if you're used to Heroku. And recently, as Google Cloud, we have started to provide some build packs of our own. Like, so this is actually pretty interesting stuff. Like, if you go to github.com Google Cloud Platform /build packs, you're going to find this project. For now, we're not announcing it. This is not production ready. This is, I would say, somewhere between alpha and beta right now. But actually, internally, we have been using this for a while. Like, we've been using for App Engine customers. We've been using it for Cloud Functions customers. And people have not been realizing that we've been using this. Like, they are not broken because we have changed the way we've been building the container images. So I want to, like, scroll down and, like, show you what's going on in the README a little bit. So we have this, like, nice chart here. This is, like, what's supported right now. As you can see here, there are limited list of languages, only 5 languages so far, but this is gonna only get better from here. Okay, like, we're working on PHP, Ruby, and other stuff, and we have function support in the languages that we support in Google Cloud Functions. So let's say you have a function, you can migrate it from Google Cloud Functions to Kubernetes, and the way to do that is actually, like, adding, like, a line here and there maybe. So this is that. Let's actually dig into it, and, like, I want to show you a demo. I'm going to go to a directory where there's an application. Okay, so this is super standard Python stuff. Like, if you have Python, actually, let's remove the README. I want it cleaner. Okay, so there's, like, only 3 files here. I'm going to look at the web.py. It's Flask simple hello world application. Nothing interesting going on here, right? It basically says import to Flask. All the requests that are coming to / I want to respond with hello world, right? And then if I request the requirements txt, it just says I need Flask. That's pretty straightforward. If I look at Procfile, now this is that file that we actually need only for Python, and other languages, actually, believe it or not, they don't need this. But Python, you can actually customize the entry point pretty heavily. So we have this Procfile. Again, if you used Heroku like 12 years ago, you've seen this. You're already familiar with this format. So here I basically say, use Python 3 and run my application, right? So all I need to do is I'm going to run pack build -- publish, and I'm going to specify a container image, and that's pretty much the end of the story. The rest totally depends on my computer speed and the internet speed. It seems like it's downloading some stuff, unfortunately. But, we're going to let this go on, okay? Like, it seems like my cache is not valid. Like, maybe they published some new images this morning, so I'm not going to make you wait for it. Actually, it seems like it's complete. Is it complete? Yeah, there you go. So, all right, so it downloaded the base image. So here's what's happening here. Like, the build packs system is pretty modular, and it detects a lot of stuff that's happening in your environment. So, for example, it realizes there's a requirements.txt. So it goes and runs the pip step so that it can download my dependencies. It realizes I have a custom entry point, and then it realizes I have a Python runtime, right? So it builds all these Docker layers, and then it actually can, believe it or not, it can reorder the Docker layers. If you didn't know that was possible, that's actually possible. We can reorder the Docker layers in build packs. As a result, as you can see here, I actually built and published an image. So I can run this image probably, like, right now. I actually have an alias that's just called run. That's just running the Google Cloud Run deploy command. Like, I'm not going to do anything about it. I'll just let this run in the background. Let's see if this completes actually very, very quickly. If it doesn't, I'm going to go on to the other demo. All right, it seems like the deployment finished. We're just waiting for container to come up. You see, I just, like, typed a command, and suddenly I went from source code that maybe I had on Cloud Foundry or Heroku, and now I'm running on Cloud Run. I can use the same command to deploy to Kubernetes, right? I click on this application. Rest assured, I'm probably going to get just hello world. Let's see, some cold start. Yeah, there. That's the hello world, right? So next thing I'm going to show is I have my function application here. Okay, so this is also pretty straightforward. Let's look at the hello.py. This is the bare minimum function that you can have on Google Cloud Functions. Request comes in, you can read the request if you want, and you can return a response, right? This is pretty straightforward. And if I look at the requirements.txt, I see something interesting here. So this is where the actual magic kicks in. I basically say, I'm using Functions Framework. And this is the Google Functions Framework that we have. And Google Functions Framework lets you convert functions into full-fledged applications. Like, we saw the Flask around it. Like, this thing converts this application to Flask under the covers, but I don't have to worry about that. So that's Google's problem, right? I don't want to deal with the Flask thing. I don't want to deal with the Flask's version and how to make it production ready. So all I need to do is actually, I'm going to run a similar command. I'm going to run pack build with a couple environment variables. So I'm basically saying that I have a function called hello. We saw that above, right? That's the hello function up here. And then I say my function is in hello.py and go publish it as an image. So when I run this, the exact same thing is going to happen. Like, I don't have to worry about, what Python image I'm using, like what dependencies I'm installing from to make, this function convert to a full-fledged application. Like, I don't have to worry about any of that. So what's happening here, again, is I realize there's a Python runtime. There's a Python functions framework this user is using, and then there's pip. So I run all these steps. As you can see, I'm reordering the layers so I can make use of the caching that I have locally. And then this is going to go ahead and publish that image. So this is going to take a while, probably. Let's see. I might actually go deploy this already. I think I built this before, so I'm not going to make you wait for it. But it seems like, so right now, it seems like it's actually pushing. That's what we're waiting for. But what I'm going to do is I'm going to deploy it anyway. I'll just say deploy this my func. I think I pushed the image before. So that shouldn't be an issue. While that image push is going on, I'll just deploy the previously pushed image. So as you can see here, I went from, there you go, something went wrong. Yeah, so it seems like, the image was successfully built up here, as you can see. And now I'm going to deploy this down here. And that's going on. That shouldn't take too long either. It seems like the deployment finished. We're just waiting for health checks, and that's done. I got the function. I can go here as well, and I'm going to get the same hello world. So that's pretty much all I wanted to show. We're getting some cold starts again. It's a cold start day apparently today. But yeah, as you can see here, that's the hello world. So that's what we achieve with this build packs. Like, we can go from source code directly to container image. Obviously, things get a little tricky when you try to install custom things into your image. But we tend to think that a lot of the people using Cloud Run, they don't really need this. For example, you showed the online boutique app. I can actually directly convert the online boutique app to an image with these Google Cloud build packs, because most of those images are pretty straightforward microservices, right? They list their dependencies in the file, like package.json or requirements.txt or Go mod file. All these dependencies are already encapsulated. So why would I bother with that? Yeah.
Cool.
So that's all I had. Yeah.
That's awesome, man. That's a good look at, this concept of function as a service, which we hear people talk about. That's a good example of, just looking at things like functions. And I think it was a good lead in with some of the teams showing the Kubernetes aspects, like there are still servers behind serverless, right? But I think it's that developer experience that you talk about and taking that, the Heroku example is a great example of just making it easy. You mentioned first time you saw Heroku and you could just push an application and not have to worry and wrangle infrastructure. I think it's the next evolution, right? Like some of us old timers, we used to wrangle servers and move a lot of cables around. And now we're saying we don't want to do that. And then now we're abstracting all this software when we start to look at it. So where does it stop? I think there's still a day two aspect of running stuff at scale for enterprise customers, but why do developers who we hired to be developers and we hired to write code and build business function and change your business and why do they have to worry about all that? And I think there's a role for everyone, and we don't need to push down that responsibility for people that want to write code and can write code. They don't need to worry about infrastructure. We have people who love worrying about infrastructure. So that's a great example. That was an awesome demo. And I guess a fun fact I need to mention is and a thank you is we use the online boutique a lot for our demos I think it was a previous hipster store, but a couple hipsters on our team got a little upset of us using the hipster store app all the time. But the online boutique app is awesome. It's just a great way to show customers like what the power of, and we don't need to, it doesn't need to be complicated, but we still should show them what microservices are and how they interdepend. And then it really shows when you start looking at service mesh and telemetry, because these things do all need to communicate to each other to provide the real business value. So maybe before we end off the live stream, what advice do you have for people? Where do they get started with this stuff? So someone who's maybe checking this out and starting to read about Kubernetes and Knative, and they want to try some things out. I linked to your GitHub repo, and I linked to the GitHub or the build packs one in the chat. But what's your advice to a developer who wants to get started? What do they need to get going?
Yeah, I would say like getting started with Kubernetes, it's not the same for everybody. Everyone has a different learning path. Knative is, I don't know. I think for Kubernetes, there are actually pretty good interactive tutorials on the website. Check them out. Knative is a little different, I would say. Like Knative kind of assumes that you know Kubernetes pretty well and you kind of understand how Kubernetes works under the covers. Like it's not super hospitable for beginners of Cloud Run. So that's why when we have Cloud Run users, we try to hide some of that like nitty-gritty details of YAML, etc. So we like abstract that away from you. We have like CLI tools, we have the UIs, etc. that you all showed. So that's why I think I would say like if you know Kubernetes, go to knative.dev. I'm also working on a book on Knative. You can have a preview at knative.tips. I'll paste that in. Actually, you can paste that in the chat probably. It's just called knative.tips. I try to like put bite-sized information about like learning Knative in a different path in the documentation. Other than that, if you're curious about Cloud Run, search for Cloud Run FAQ. I also have a repository that explains pretty much everything you might be wondering about Cloud Run. That's the learning path that I would recommend. Otherwise, just get your hands dirty, try it out. You know, as Kyle said, our job is to maximize developer productivity the way I see it. And we internally at Google, we do a lot. We invest like probably hundreds of millions of dollars to increase the productivity because we have all these engineers that we hired to code, and they probably shouldn't spend their time debugging issues, worrying about infrastructure, right? So I think this really resonates well with the external developer community as well. And I'm glad this is finally happening.
Love it.
Yeah.
So keep doing a great job as a developer advocate. I know we had a conversation a while ago with Kelsey of the difference between developer advocate and the old evangelist that we used to have, like the ambassador, Solaris ambassador. And I mean, he described it well. It's all about looking at it from the developer's perspective, unblocking them from issues, and getting the message to the product teams at Google too. Is like here are the stuff we need to work on to make the experience better. And I think he also made, no one's ever winning in this game. It's all temporary. And I love the communication and the collaboration that we are seeing in the open source community. This is not all being driven from one group. It has a lot of perspective and a lot of different people that care about it. And I think that's how we build better software and get it to users much faster.
Yeah, absolutely agree.
Cool. Well, I think that's it. We ran a little over, but we got some wicked content. So we'll make sure we share the restream after Google's fantastic farm of servers is done rendering this one. We'll get it out. And just wanted to thank you for joining, man. We'll get some of your links out to the community so they can kick the tires with this stuff. But everybody enjoy their day. And we're going to do another one of these in a couple weeks. And it's going to be more of an Anthos and friends event. So we're going to start to bring in some community, some of our partners, some ecosystem partners of tooling that starts to complement this stack. So there's lots of room in the ecosystem for other people, and we want to start to show off some of that stuff. So keep an eye out that one. I think we're going to push it a day. It'll be on Thursday instead of Wednesday in 2 weeks, but we'll share the link and sign up for everybody, and team will get cracking at building some new content. So I want to thank everybody for their demos. Wicked job, guys. You can I'll go relax now. I'm sure you were cramming late last night, as always, getting this stuff ready.
That never happens, Kyle. Seriously, never happens.
I do get notifications on the repos, and I'm pretty sure I saw a couple pushes like up to about 2.5 hours ago. So
I may or may not have that Cloud Run FAQ repo started, by the way.
Yeah. Perfect. All right, guys. Well, have a good day, and everybody, thanks for joining. We'll see you again on the internet. So take care.
Thanks a lot. Thanks, Ahmet, for coming.
Thanks, everyone.
See you guys.
See y'all.
Cheers, all.